On December 30th, 2024, the US Treasury Department announced that the state-sponsored Chinese hackers had apparently breached the department's systems. The attackers got in through a tool called Beyond Trust, a remote support software, and there was a bug in their database that had been sitting there for years, just waiting to be found. What you're about to see is just how 2 bytes was enough to expose a fundamental flaw in the Postgres database, one of the most, or if not the most, used database out there. A flaw that is so simple that it challenged our core assumptions about preventing SQL injections in the first place. So, without further ado, let's get to it. A portion of this video was sponsored by Snyk. More on that at the end of the video. On December 5th, 2024, Beyond Trust, a company that provided remote support software to the US Treasury, detected something unusual in their systems. 3 days later, on December 8th, Beyond Trust had to make a difficult call to the US Treasury to let them know that their system has been breached. When the news got around, people started digging a little bit deeper. When the security researchers at Rapid7 started analyzing these patches, they found something unexpected. Even with proper escaping in place, even with following all the security practices, there was still a way in. For decades, developers have been following one simple rule to prevent all kinds of SQL injection attacks. Always escape your inputs. Every time you take the user's input that needs to go into a database query, you escape all the special characters like quotes to make them safe. Consider this simple example of a login query. Here, I'm trying to query a user in the database with that username and password. But if I enter this password instead of I'm Batman, our query would look something like this. Now that single quote breaks out of the password check, and since 1 is always equal to 1, and this query cannot be false, you're now logged in as Pwn function without using the real password. And this is why you can't just copy users' input into database queries. We always need to escape special characters like quotes just to make them safe. And in the case of Beyond Trust, they were in fact removing special characters to make their query more safer. But how on earth did the attackers still manage to get in? Well, the answer is that. Just 2 bytes. Pretty simple, isn't it? How are these seemingly harmless looking bytes responsible for all of this? Well, to understand this more, we have to dig a little deeper into the source code of Postgres database. Now here where things get really interesting. Beyond Trust used a function called pg_escape_string so that it can safely escape any special characters that the user input has. And it's quite a standard practice. You pass your input through this function and it handles all the escaping for you. But looking beneath the surface reveals a concerning reality. When you call pg_escape_string, it doesn't just do the escaping itself. Instead, it makes a call to the Postgres native function, and things go a little bit deeper. You can always follow the call stack that I've provided to know where we are in the source code. Okay, so now let's look at a core function that determines how many bytes make up a character. This is done with the function pgutf-mblen, and every piece of text that needs some sort of escaping pretty much goes through this function. And this is how it looks like. You know how some emojis or characters from other languages make up more space than a regular English letter? Well, that's basically UTF-8 encoding at work. While the letter A is just 1 byte, a character like this, an emoji, might need multiple bytes to represent it. And the Postgres database needs to handle this correctly when it's actually escaping strings. Now here's the crucial part. If the first byte is 0xC0, it's gonna think, this must be a 2-byte character, so I'm just gonna set the length to 2. And it does set the length to 2. Now this length variable gets used in the code here. Now look at this line very carefully. It's basically copying all the bytes from source to the target, trusting that the length that we got from the pgutf-mb-len function is correct. It never really checks if these bytes are actually valid UTF-8 characters or not. Now what if we set the second byte to a single quote, 0x27? Now the first byte, 0xC0, says, hey, I'm the start of the 2-byte character sequence, and the Postgres database will look at it and say, okay, I'm just going to copy the next byte as it is. It copies both 0xC0 and our sneaky little single quote without escaping. So how did attackers really use this bug? Apparently, Beyond Trust's remote support software had a component that accepted a parameter as the user's input and sent it to a PHP script. Now, the script was properly trying to escape all the dangerous characters using the pgescape function, but we just learned how to trick that function into spitting out unsafe SQL queries with our 2 magical bytes. This unsafe string gets passed into a program called PSQL, which is basically a command line interface for Postgres database. But the interesting thing here is that it has a feature that could execute system commands, so pretty much a game over. By December 14th, Beyond Trust had patched their cloud environments, and 2 days later, they announced the vulnerability with the patches for all the customers. And moreover, the true scope of this vulnerability became a lot more clearer in the January of 2025, when Rapid7's analysis revealed the underlying Postgres flaw, a bug that potentially affected millions of other systems worldwide. The fix for the Beyond Trust products was pretty straightforward. Beyond Trust added a simple check that only allowed letters and numbers as the user's input, so no special characters or complex bytes, none of that. And on the Postgres side of things, they also did release fixes for all the supported versions. If you're running PostgreSQL more than 13 version, I believe, you should be good to go, but do check out their website just to be safe. Speaking of fixes, when was the last time you checked what kind of vulnerabilities were hiding in your codebase? Tools like Sneak can actually help you catch these kinds of issues early on in your development pipeline, even before they actually make it to production. Having security tools integrated with your development pipeline is not just, a nice to have feature anymore, but more like an essential practice that helps you catch vulnerabilities early on in the process, saving you a lot of time and also reducing risk. Get started with Sneak for free at sneak.io. This US Treasury breach revealed something surprising, a fundamental database flaw that challenges our security assumptions quite a bit. It's a humbling reminder that in the world of security, our strongest assumptions often deserve a second look.